Today's date is 17th of May 2026. Time now is 8:48 p.m. So today's date is 17th of May 2026. Date now is 8:48 p.m. So so I'm gonna be going to Nigeria. Very important I say that, but I'll keep working on things. I've stopped doing the compound model, so I can focus on Nigeria while working on other problems. So this is just the art here. This is the art here. This is the art here. So this is the compound so far. So this paperwork here. So here. Here. This is the work here I did. This works like that's the work that but it's just the work here. So I'll be drawing a bit more when I get to Nigeria. What is this video about? It's a pitch note recording this video. Yes. Charic geometry. Charic geometry. CHIA. CHIARIC. Charic. Meaning Charic. Charic. No, not secret. Charic. Charic meaning in geometry. Geometry. Geometry Charic. Basically, there's something there's a definition I wanna find, and this is Charic geometry. So, what is Charic? What is Charic geometry? Charic term. Okay, basically, I'm looking for the term Charic in geometry. See what this means. So I diary update. So on it, Asymetric. Another no. So basically, let me solve the concept by first principle. I'm trying to formalize this here on the paper. So take a regular polygon. And so we're gonna have a cube regular polygon, which is a sphere. It's not a regular polygon, which is a cuboid. A cuboid like this, and we have an axis symmetry here. Yeah, so here so basically this is the shape and symmetry. So geometrically it's a rectangular cuboid. That's according to the chart. So let me try to remember find what I mean by that. So rectangular cuboid. Let me find the volume and area and stuff like that. rectangular cuboid. Rectangular cuboid is an octagonal prism. It's a 3-dimension 6. A rectangular cuboid. So yeah, it's a triangle, but it's a rectangular cuboid. So it's basically a cuboid, but it's a rectangle. So it's basically this shape here of Wikipedia. So what I'm trying to say here, if you have two rectangular cuboids and they are placed on top of each other and just rotating 90 degrees at an angle, at the top of the angle, you have this shape here. So you have this system here. So basically now they are now if you put in front of a mirror, if you put this shape, if you stack this cuboid on another cuboid and you rotate one of the cuboids, at 90 degrees angle at the edge of the cuboid and rotate, that's what I'm talking about here. So what am I meaning here? So there's the principle of Charicness. So Charic, what am I by that? So the problem I'm trying to identify is something here regarding this system for the holographic interface. Because if you have let's use the term, if you have if like you have x, y, z and you have t of time interval is not needed. I mean, it's needed, yes, but let me think. Mom, let me think. So you have XYZ coordinate, but you have an area of the system. So basically, you have two cuboids stuck to each other, but one is rotated 90 degrees, and that is basically at the edge of the rectangular, prism. And the goal of this, what I'm trying to express here, is that this shape is literally orthogonal. I mean, it's a right angle, and you have the principles that work together to give the shape nice and lean. Basically, if this shape, if you reflect the shape on the axis of, if you get a mirror and rotate it 90 degrees. It's my work of art I did a long time ago, but it's not work of art I did a long time ago. It's something I did. So if you have no, it's not artwork, by the way. Blah blah. If you have this artwork here, you have something here. You have to reflect on the other side. So basically, the reflection on the other side basically be a 4 dimension. And the problem with the 4 dimension is formation is time. You can have a 4 dimension of time, and the 4 dimension of time is not dimension. You can have a 4 dimension of time. You have a 4 dimension of x. Basically, I'm saying that I'm not claiming anything. I'm hypothesizing. So you can have time, you can have asymmetry of time. So you have this symmetry here, symmetry line here, and that symmetry line is in 3 dimensions because it goes this way. I'm not really framing something stupid. I'm saying that, the fact of the matter is, you have axis symmetry, a line here. But this line is a plane. So basically, a plane, you have a plane, not a plane. So you have a plane. A plane is a kind of symmetry. So when you reflect on a plane, you are reflecting in the 4th dimension. And that 4th dimension will give you the wireframe on the other side. So, basically, you can have the Z buffer. So you have X, Y, Z, W for width. X, Y, Z, W for width. But this width is a 4-dimensional property, so it's not good to just call it width. It's a 4-dimensional. So it can be a time. It can be different parts. So T for time, or delta. change in time, delta t, because you can't define time, in a good way, because so we don't know what time is scientifically, but mathematically it's a measure of passage of something passing by in the system. What is time? No one knows. So basically, I'm framing the W. Also, if you have x, if you have a vector component of vector 4, it's homogeneous. Homogeneous. Because it can work on all kind of. It can work on vector 3, vector 4. It's heterogeneous. See heterogeneous. Same type, same kind. Same type of vector. Vector 3 can work with the vector 2. Vector 2 can work with the vector 4, because you have the other dimension of vector. But the thing I'm framing mathematically, what I'm framing here is Namdi, get this. Is you have a plane. The plane equation is defined as ax plus by plus c. The equation for plane. Let me find that. I think it's as squared plus by equation for a plane. The equation for a plane. ax plus by plus cz plus d equals 0. This plane lies at the right line of 0, and that's what that means. So this is the equation for a plane, and this plane is literally on a surface. This understanding equation, so you get point normal form, point slope form. But all these properties go to 3 dimensions, so you get a new kind of math, instead of form x squared plus b from this one, and you have geometry. This is a new kind of geometry I love, this kind of what I love, I've seen all of this before, but now it's in 3D, so you get a plane, and you get the shape on the surface of the normals, projecting on the surface, without a camera, because without a camera, because this is it's not the thing to call the camera, because the color can go to the camera, but I'm saying that you get the equation of a plane, ax plus by plus c equals plus d plus cz plus d equals 0. The points normal form, which is basically the normal from the normals, the point slope form, or the point normal form. So you get a point slope form, and you get a point normal force, where there's a point at the surface of the on the surface of the on the face. Basically, it's something to do with univectors. Univectors, but it's the magnitude divided by. I can't remember what the point normal form is, but I assume it's the normal faces that's computed by the magnitude, the ratio. It's a ratio divided by basically you get the magnitude. The magnitude divided by the area, section, the actual point, which gives you the normal for all the components in the point, and you get intercept form, which is ax x divided by a divided by but intercept form basically the point is touching the line, tangent point touching the line, which is 1. You get slope intercept form, and you get point intercept form. But you see, all these concepts came to 3D. And wait, can you see the screen? Yeah, you can see. But I'm saying that the idea is to have a reflection, something in 4 dimension. Basically, you are computing a 4 dimension. Because basically you got a buffer. So the way basically you don't compute. So for me to just reflect this shape on the other side, which I call a hologram, it's kind of silly, but I don't think it'll work. Basically, you have this package I'm working on. Let me get it up. Rubik's Hollow. Yep, and you have this index of which is just one file, and you have download this one file. So this is the render I had before. MX is live. Oh, they're live. Mozilla. Okay, I'll come on to that later. So basically, you have this here. You have the morphing. So you get this shape here, and it's basically a torus and a cap. The torus. This is a torus here. It's complete. You know, basically, see all the lines is complete here. But the problem I have is this cup here. It's not complete. You know, it doesn't morph. It doesn't morph. It morphs, but it doesn't complete the morph. And you know, it's not that you know the math is wrong. I believe the math is wrong. My math would be wrong, but I don't believe it's wrong. You know, it's not wrong. I would say, you know, it's a cup has 2 holes. You know, basically from the faces of the shape, because it has 2 holes because it's facing. You know, basically the cup has 2 holes because you get 1 hole in the enters and 1 hole that that you can leave both holes. But it's like a knot, you know. Basically, you're gonna have the dimension like this. But you see, it's not complete. It's not complete. It's not even complete. You get a hemisphere. Yeah. See, the thing is, this is a hemisphere, and this is not complete. So you know, this is a hemisphere. It's a half a sphere. It's called a hemisphere. So it's complete, you know. But you know, this is complete. No, this is not complete. Is it? I can't rotate it. I can't panic. But the goal is, you know, the goal. What I'm saying is the cup is not complete here, and the cup is here. So you're gonna have the cup. Basically, I'm saying I'm trying to reflect this into the 4th dimension. So by reflecting to 4th dimension, I'm not like using 4th dimension properties. I'm thinking. Let me think. So you have the shape of the cup, and the shape of the cup is having 2 holes, but you know, when it morphs, it has 2 holes, the same one, but starting from the faces, because the face is where the holes start. You know, there's a hole in the face, and that hole is basically an edge that's not connected. You know, but the problem is that, you know, that cup and that torus are the same shapes, the same topology. They are the same shape when they morph shapes. So my math, I believe I'm right. I know I'm right. You know, it's just that I haven't completed my demonstration. Is not complete yet. So that's what I'm saying. That. So okay, let's go to the video. So basically, it's like that. So what am I trying to do now? So you know. So basically, the plane is like, you know, basically I'm trying to rotate the 4th dimension. Basically, you can what I'm trying to do is take the surface, the plane, reflect it on another dimension. Reflect it on other dimension, and I'll be like, you know, see, you know, basically the plane is not working. No, what am I saying? So the system won't reflect. What I'm saying is that, you know, you have the cube, the rectangular cuboid, and you know, basically I'm trying to reflect it as a vector, as a plane. So you have a plane taking a 3D shape and performing circular rotation, and something called Charic. So a Charic geometry. So doesn't matter how much I flip or rotate the shape, it's symmetric. You know, it's basically the plane will preserve the property on the other side. You know, on the other side of the buffer. So basically, the data that's been it's called Charic. So that's what I'm saying, Charic topology. I don't know what the term stands for. You know, Charic. I know what it means, but I know what I'm saying, because, you know. So if you have the term Charic, meaning in 4D, Charic, geometry, 4D geometry. So Charic equal to first definition. Oh no, there's no NHS, no fucking NHS nonsense. I don't care about NHS nonsense. They abuse people, man. Charic, yes. This is what I'm saying. So this is a four-dimensional map. 4 dimension. But the 4 dimension is not time. It's not time. It's not time. It's not space either. It's basically, if you define it properly, it's something we can define ourselves, and that's what it is, you know. Because if there's no XYZ, we can't define. We just define it because you say it's its own dimension. But you know, it's 4-dimensional. Basically, I'm trying to do some research here. I haven't done proper research in such a long time myself, but you know, I need to start doing proper research. You know, I love researching. So on the dimension or fun dimension. So you know, basically, I'm trying to reflect this shape on the other side. So basically, also reflect. So if the actual symmetry is a camera, if the symmetry, if the Sloan Siki, if the camera here, if the plane is like, you know, if the plane is here, I'm not doing the maths. I've written a mathematical equation, which is annoying to me. So a line, a plane, a volume. So basically, I'm trying to reflect across the plane, and basically to preserve the Charic properties, and then perform the transformation of morphic stuff. Because you know, it can reflect a torus and a cup. You know, if I don't preserve the shape while computing the Z buffers, it will be a problem for me to do later. But you know, that's what I'm saying. So you know, basically, it's basically the problem I'm having right now. What's this? What's mine? Why do you subscribe to me? Oh, why did you subscribe to me? You know it's AI, but why did you subscribe to me? Why did you even clap? Why did you even clap? Basically, this is why it comes my story. I use AI to generate all that crap, but you know, let me just try to use my Dev.2 account and move this stuff now deviated. But you know, Dev.2 / OBINexus. Homeless guys telling me I should believe authority should. Anyway, these people are funny because when it comes to do the job, they don't want to do the job. You know, UK is so like that. You know, them going to other countries to work. You know, for me personally, it's the best bet. You know, so basically, like I was describing the shape of the whole system. Gonna have this shape here. So this is the structure. You're gonna have that there. You're gonna have the this cuboid here. You're gonna have that symmetry here, and by this kind of reflection on this kind of symmetry, you have kind of this is not rotation reflection. You know, basically it's a carry shape. Basically under a plane, the plane is the mirror, and the plane replaces it on the other side. So you basically that's what mirror is doing. This is what mirror is doing. That's what, because the kind just reflects it, but you know, oppositely, you know, just time, you know, replaces it, but in the opposite, not time. It's not time. I just say it's not time. Basically, it's whatever this mirror I'm trying to do. Whatever this mirror is doing is what I'm doing, but with shapes. Then I can move them. Basically, then I can move them because it's not correct as a hologram. This is a projection of me in a different way. It's a projection of me, but it's a holographic me. I don't think this is one thing. So what this mirror is doing to my body is literally what I'm doing. As I move my hand, you know, is doing what I'm doing, but you know, I'm doing it because if this represents the competition of the digital world, you know, if this represents the real world, and I'm interacting with it, you know, I'm interacting with the inverse of it, you know, but you know, I am interacting with this entity. Let's say this pen, you know, this cube, this shape here, this shape here, because the mirror reflection of this shape I'm reacting to, and this when I rotate it rotates that way. It's a Charic transformation, and you know when this shape rotates one way and it goes the other way, you know, it's basically gone through 4 dimension, and that 4 dimension it's like, you know, what this mirror is doing. So that's what I'm trying to do. That's what I'm trying to do to rotate it properly. Let's see what I'm saying. So that's the goal of this video. And then I can apply the buffers and stuff like that. But it does work. It does work and fail. So you know.